Trigonometry. We are tacking on CO25 to the beginning of our next unit. We kind of ran out of time before Chris's break, but we'll get it done now. It has to do with equilateral and isosceles triangles. We've talked about these triangles before. You should know what the relationships, exist between isosceles and equilateral triangles. So let's just review quickly. What is an isosceles triangle? What makes a triangle isosceles, Jack?
It is two of the same sides in one.
Okay, so an isosceles triangle, it has two congruent sides. What's that?
Where are we supposed to write that?
Right where I did, maybe. Okay. But what you might not know about an isosceles triangle, when you think about it, makes perfect sense. And it has to do with the base angles theorem. The base angles of an isosceles triangle are the two angles at the base, the two angles opposite your congruent sides. What would you guess is the relationship between the base angles of an isosceles triangle? Aiden?
They're congruent.
They are congruent as well. Okay, so what we know here is in green. What we can conclude is in red. When you have an isosceles triangle, the base angles theorem says that if two sides of a triangle are congruent, essentially meaning that you have an isosceles triangle, but you're given the information the two sides are congruent. So if two sides of a triangle are congruent, then the base angles, there we are congruent. Okay? If two sides of a triangle are congruent, basically it's not an isosceles triangle, then the base angles are congruent as well. Yes?
How come as you're saying it, you say the as you're writing it, and you say the after?
I have never noticed that before, but now that you mentioned, it's all I'm going to be able to think about. I don't know if I'll be able to continue this lesson thinking about that. Really?
Yes.
Do I do that?
You literally just did it.
Well, just I did it once, so I do it every time?
Yeah.
Now that I think
Weird.
about it.
Don't. Let's not think about that. Aye, Alice. So if you recall, Joey, enough. In the back of your book, starting on page 926, it's got a list of all the postulates and all the theorems that we're covering. Lisa, warning for you. And so 4.7 is, it tells you where in the book you can find this. Chapter 4, section 7 is where in the textbook they talk about the base angles theorem. Or maybe it's not, maybe it's it's the seventh theorem in chapter 4. So converse, which will be the same lesson, will be the eighth theorem in chapter 4. So it just has to do with where in the textbook those things occur. Lisa, do we need to go out in the hallway
I'm sorry.
today? Are you really?
Yep.
So that means that you're going to stop and start paying attention. Okay? All right. The converse of the base angles theorem, converse, of course, just kind of means the same thing but backwards. So in the converse of the base angles theorem, I'll draw a better isosceles triangle here. That looks the same. Hold on. Third time's the charm. Come down like this. There we go. In the converse of the base angles theorem, we know the base angles are congruent. Joey, back to seat behind you. I'm done with you and Rowan. Go. I'm done. Go. Go. Just because you're not saying anything doesn't mean that you're paying attention. And it doesn't mean that you are not distracting others. Okay? In the converse, we know the base angles are congruent, and therefore we can conclude the triangle is isosceles, meaning it has those two congruent sides as well. So the two ways to determine whether or not a triangle is isosceles, number one, you're told kind of what you're used to. It's got those two congruent sides. We can then make the leap the base angles are also congruent. But if you know that the base angles of a triangle are congruent, it means it's isosceles because we can conclude the sides are congruent as well. Okay? So in words, the converse, if the base, I just did it, didn't I? Anthony. If the base angles of a triangle are congruent, then opposite sides are congruent. Okay? If base angles of a triangle are congruent, then opposite sides are congruent. So again, like we've seen before with theorems and converses, we are given one piece of information, we can conclude the other. We can reverse that. If we're given one piece of information, we can then conclude the other. Okay? Questions on that? All right. What's an equilateral triangle? This is more of a definition, but yeah.
All the triangles of the same size and angle.
All angles and sides are congruent. And specifically with those angles, what measure does each angle have? Not 75. Not 40.
180.
Not 180. Each angle is 60, right? Because every triangle will have exactly 180. 60 times 3 is what gets us to 180. Okay. Questions on this? Okay. The rest of it is essentially practice with this information. If you are given the diagram here, what type of triangle is this? Aiden,
Isosceles.
how do you know that?
Because the base angles are congruent.
Right. With those two base angles marked congruent, we can then conclude that these two sides are congruent as well. Which means we now have a relationship between 5x plus 5 and 35. The equation we can set up is that 5x plus 5 is equal to 35. Damien, go ahead.
X equals 6.
And then we can work that down to x equals 6. Okay. Next one, you're going to have to solve for both x and y. Someone give me a relationship that we can write based on the information given. What can you conclude about this triangle and its relationship? Alexis?
X plus 7 equals 55.
No?
Yeah, that works. No, but
Christopher?
X plus 7 equals 55.
Correct. Okay. We know, since it's an isosceles triangle, the base angles
actually makes me
are congruent. And so the relationship we can set up, x plus 7 equals 55. We can conclude from opposite operations that x equals 48.
plus 55 is.
Huh?
I'm
55. The
What?
correct way to say it.
Morning for you. How do we get y now? Oh, would you like to take this one, Alexis? Sorry, I feel bad. No? Okay. Kylie.
You shouldn't feel bad, Mr. Schultz.
You add
Hurt her feelings. Yeah, she's gonna cry herself to sleep tonight.
Go ahead.
you multiply 75.
Folks, shh. Kylie.
I know it.
Multiply 55 by 2, which is 110, and then subtract it from 180, which
Yeah.
is 70.
We wouldn't even necessarily need to solve for x first to find y, right? Because knowing these base angles are congruent and knowing the one on the right is 55, even without knowing x is 7 or 48, we already know the other one is 55 as well. Okay, so we wouldn't need x first necessarily. But as Kylie said, 55 and 55 is 110. We know the triangle contains 180 degrees. So 180 minus 110, y is going to be 70. Okay, Damien.
Could you just add 55?
And what?
Add 55.
No, you could not do that.
55
Nope.
and 48.
No.
And then you
And then you get that answer, and then you 180 minus the answer that you get. Yep.
Nope, that doesn't work.
Yeah, it does. Good job. It's 55. That's what. Here, I'll show you that works.
Okay, you work on that. Next one. What do we do here? What type of triangle is it?
Right.
Bryn. Right triangle, which means what do we know about the two acute angles of a right triangle? This particular one, because not only is it right, it's also, Arlene, is also isosceles, right? We are given those two markers there. So what we're going to learn more about these triangles coming up, but what do we know about the acute angle measures of this particular right triangle?
You could do 9y equals x, or you could also do 9y plus x equals 90.
Okay? Even whenever we put two variables in the same equation, we're dangerously dealing with Asher Oy, which I know gives some of us the heebie-jeebies, PO40 from last year, if you recall. But knowing this is an isosceles triangle, and it has a right angle, what do we know about the measures of the two acute angles? They are less than 90, that's correct. Aiden?
They add to be 90.
They have to be 90, and they're congruent, meaning
They have to be the same.
they have to be the same, so they are 45 degrees, right? If you're dealing with an isosceles right triangle, you know that 90 of our degrees are taken up by the right angle. And you're all correct. You said the two acute angles have to be the same. They have to add to 90. Therefore, the only option is for each of these angles to be 45 degrees, right? Which means we have x. X is the angle itself. X is 45. Y, 9 times what number equals 45? And we get y to be 5. Okay? Damien.
I want to ask the.
We're already past that one.
I know, but it equals 77. Y equals 77.
I told you it wouldn't work, Damien.
I don't think so.
I told you it wouldn't work. I don't know why you just didn't trust me. I mean, it could not have worked out any better for me. What just happened here? But no, it's not 77. What you forgot in your little quest was to add the 7 there. So that's how it got. But I told you it wouldn't work. I did give you a heads up. Next 3 here. Why don't you take 5 minutes to work on these 3 with your partners, table mates, and we will. This is work time. We will reconvene in a second. Now, all right. Tell me the relationship you came up with or your thought process for x and y. Rowan.
I did 132. 180 minus 132
Okay.
was 48. And then the two angles are congruent.
They are.
Yes. And so 48 divided by 2 is 24.
Good. So both x and y equal 24 for exactly the logic that Rowan just provided us. You know it contains 180 degrees total. You're given the 132. To subtract 132 from 180, you're left with 48. These two angles are congruent because of the base angles theorem. Therefore, divide that 48 by 2, cut it in half, and you get 24 degrees for each variable. Next one. Who wants to share? Liesl.
Since I know each side has to equal 11,
Yes.
so the first thing I did was 11 equals 2x minus 3, and then I solved that to get 7. And then I did 11 equals y plus 4, and then I got 7.
Okay, both x and y equal 7 for the exact reasons Liesl provided us. We know it's an equilateral triangle because all 3 angles are congruent. So all 3 sides are congruent as well. If one side's 11, what value for x would make 2x minus 3 equal 11? That value is 7.
Go home.
Damien.
As well as Mrs. Today, as well as Mrs. Pepco. Could you come to the office if you are available? Thank you.
Likewise, x or y plus 4 needs to equal 11 as well, and 7 satisfies that. This last one, a little bit tricky, perhaps. What did you come up with or maybe not, actually. I'll look at it again. Those two variables always make me nervous, but Aiden?
So, it's an isosceles triangle.
Indeed.
So 2x minus 11 equals y plus 16. And then they both have to add to equal 90. And since they're congruent, because it's an isosceles triangle, they're both 45.
I'm gonna go that route. Setting up that first equation, 2x minus 11 equals y plus 16. Again, placing two variables in the same equation and trying to solve it from that, bring us into Oxenoi and a system. The last thing you said is key. We know they're both equal to 45. Therefore, we can set them equal to 45 separately. 2x minus 11 is 45, which means that x equals 28. And y plus 16 is 45, which means that y equals 29. Okay? Questions on any of those? Okay, your assignments for tomorrow. I am giving you homework.
Oh, I forgot that's all bad.
If you have a snow day tomorrow, then it's not due until Wednesday or Thursday.
Do you not know that?
I have it there. I have it there. I just have to hand it out. All right, folks. I'm going to leave this up to you. Do you want? This is a would you rather question. Would you rather?
I like this.
Would you rather have more questions but have them be on the easier level of difficulty, or have fewer questions but have them be on the more challenging level? That is all I'm going to offer you.
If it's like this,
Actually,
Here goes. How many questions is for each?
Raise your hand. Raise your hand if you would rather have a sizable homework assignment, but have them be on the easier side of things. Raise your hand if you would rather have fewer questions, but have them be on the more challenging side. On page 268, you are to do 32, 33, and 34. That's it.
Yeah,
Are those hard? I'm guessing
That's why I said
and y'all wanted more.
Nope. Make sure you show your work. That's how I math.